Hello all, let us solve today's LeetCode daily challenge. The question is min cost climbing stairs. The question is you are given an integer array cost where cost of I is the cost of ith step on a staircase. Once you pay the cost, you can climb either one or two steps. So you can either start from the step with index 0 or with the step with index 1. Return the minimum cost to reach the top of the floor. So here we are at the index 0, we have to take either one step ahead or two step ahead. So for this is satisfies the condition for each index. I can take either one step or two step. For this index I can take either one step or two step. For this index I can take either one step or two step. So what will be the maximum what will be minimum cost to reach the top of the floor? I'm asked to find it. So let us since it says either one or two steps, this is similar to the climbing stairs problem that we seen before. So we will write a recursive function return solve. This is going to give me, this is going, I will pass the parameters cost and the index 0, or I will come from the end. So both are same, so I will come from the end. Cost dot size in n, so n minus 1. So for each index I can go either one or two steps. So in solve, this is going to give me the minimum cost value. Int cost which in solve which takes the parameters cost container and the index I and inside which I have two options. In option 1 I can take this cost. If I take this particular value, if I'm going to take this particular value, then I will be going to my next one or two steps. Once you pay the cost, you can either climb one or two steps. Okay. So here my option 1, what will be my option 1? Here they have given you can either start with from the index 0 or with the index 1. So as we are coming from the right hand side, so we will be either come from the last index or my last before index, so which is n minus 2. So I will take minimum of both the cases. So my what will be my option 1? I can take the current cost and then I will be going to one step further. So I will pass cost and I minus 1, and I will write in option 2. I will take the current cost and then I will go two steps further, I minus 2. So and I will finally return my minimum of both the options. So let us define the base cases here. Base cases. What will be my base case? If my I is equal to 0 or my I is equal to 1. Since if I reach either I is 0 or I is reached 1, since I can start in either of the index, so I will just return the cost of I itself. So this will be my base cases. So we will just run the code now. Sorry, it is private column. So here the time complexity will be exponential in nature. Here for every index we are going to take two options, two recursive calls. So it will grow exponentially. So yeah, we can just memorize it to reduce our time complexity. So we will to memorize it we must declare a DP array. First we have to see what are the changing parameters. The changing parameters is only one index, only one variable. So we will declare a 1D array, namely we can say it as dp of size n, and we will initialize it to -1, and we will pass the dp to our functions, and even we will be passing the parameters as dp of dp, and we will say vector in, we should pass it by reference dp of I. and now we have to cache it, we will have to memorize it in our return statements. And if my dp of I is already computed, if my dp of I is not -1, then I can obviously return dp of I itself. So we have just memorized it. So here what will be the time complexity of this memorization solution? We are first seeing the recursion approach. The time complexity will be growing through exponential, and then we are doing a memorization. For this, the time complexity will be order of n, and the space complexity will be order of n plus order of order of n, which this order of n is auxiliary stack space. So this is the memorization technique. We can try to submit the code. So we have used recursions, for which in recursion we will be using extra space of auxiliary order of n. This is for auxiliary stack space. We will try to eliminate it by using a tabulation method. In tabulation we can eliminate this auxiliary stack space. Let us see how we can do here. So to convert the memorization into an auxiliary into a tabulation method, we have to first initialize the dp array to be 0, and then convert this solve to be dp of that particular indexes. If it is the function is called of dp solve of n minus 2, then it is dp, we have to take dp of n minus 2. And then we have to define the base cases. What will be the base cases? If my I is 0 or if my I is 1, I am just returning the cost of I. This is my base case. So dp of 0 is nothing but cost of 0, and similarly dp of 1 is nothing but the cost of 1. Next I will run a loop from 2, I is 2, I less than n, I plus plus. While I am running the loop, I will just copy this recurrence relation and just paste it inside our solution. So now we don't want this recursive function at all. So here we will take this dp, and then we have to convert the solve to be dp of I minus 1. It is that simple to convert a memorization to a tabulation. dp of I minus 2. That's it. We have done. We have handled every cases. We have defined the base cases, and then this is the bottom-up approach. We are building the base case, a small solution to a bigger problem. So finally, we are returning the minimum of the last and last before index. So there will be it will be the is what we have called the function. So in this tabulation, the time complexity will be order of n, and the space complexity is also order of n. We have eliminated this order of n auxiliary stack space during recursion. So we will try to run the code. So we will try to submit. This also got accepted. So here we have optimized it to a linear solution with time and space. So here we are using for calculating the current value. For calculating the current value dp of I, we are just using the previous value and the second previous value. So instead of maintaining a whole array, we can just declare two variables, int previous and second previous. And my dp of 0 is nothing but the second previous, and this my dp of 1 is nothing but the previous. So this dp of I minus 1 is nothing but my previous. The dp of I minus 2 is nothing but the second previous. And we are going to calculate this current value in current. But consider we have 1, 2, 3. So here this will be my second previous, and this will be my previous, and this is going to be my current. So for my next iteration, this second previous is this 2 is my second previous, and this 3 is my previous. So we have to update these values. So what we can do is the second previous is my previous now, and my previous becomes my kernel. We are coming like this fashion, you won't get confused. The second previous becomes my previous, then my previous is nothing but my current. So now we have updated the values for our next iteration. So we have and finally we have to return the minimum of the previous and second previous. So we will just run the code now. We are using only two variables for to compute this. So we will try to submit the code now. And here what will be the time complexity? It got accepted. So we have done a space optimization as well. Space optimization. For this time complexity is order of n. We are linearly traversing the array, and the space complexity is order of 1. So we have gone through the recursion approach, then we went through the memorization, then tabulation, then the space optimization. So hope you like this video. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.